On the night of August 15, 1977, a radio telescope in Delaware, Ohio, picked up something that should not have existed. The Big Ear Observatory, a massive array of metal and wires sprawling across an empty field, was doing what it did every night, listening to the sky. It could not move. It could not aim. It simply waited for the Earth to rotate beneath it, sweeping its view across the stars like a lighthouse beam that never turns. At 11:16 p.m. Eastern Time, a signal arrived. It lasted exactly 72 seconds. It came from the direction of the constellation Sagittarius, deep in the Milky Way. The frequency was 14 to 20 megahertz, the exact wavelength where hydrogen, the most common element in the universe, naturally resonates. Astronomers call this the cosmic calling card. If you wanted to send a message across space, this is where you would broadcast it. Because anyone listening, anyone with even basic radio astronomy, would know to tune in here. The signal was strong, 30 times louder than the background hiss of deep space. It rose sharply, peaked perfectly, and fell away in a smooth curve, the exact pattern you would expect if a distant source were passing through the telescope's fixed beam as the Earth rotated. No randomness, no noise, just a clean, deliberate arc. The astronomer who reviewed the data printout the next morning was so stunned, he grabbed a red pen and circled the sequence. In the margin, he wrote one word: wow. That astronomer was Jerry Ehman, and for the next 48 years, he and dozens of others searched for that signal again. The Big Ear listened to the same patch of sky hundreds of times. Other observatories joined the hunt. Decades passed. Silence. The signal never returned. Theories piled up. Maybe it was a comet releasing hydrogen gas as it heated up near the sun. Maybe it was a classified military satellite. Maybe it was interference from Earth, a glitch in the equipment, a cosmic burp from a distant quasar. But none of the explanations held. Comets do not emit powerful radio waves at the hydrogen frequency. Satellites do not produce that kind of signal curve. Glitches do not follow the precise mathematical pattern predicted by celestial mechanics. The wow signal became a legend, an unsolved riddle, a single scream from the void that was heard once and never again. Until now. Because in January 2025, astronomers tracking a newly discovered interstellar object, officially designated 3I Atlas, the third confirmed visitor from beyond our solar system, ran a series of routine calculations. They traced its orbit backward through space, rewinding its trajectory like a movie played in reverse. They wanted to know where it had been, how long it had been traveling, whether it had passed near any known stars on its journey here. What they found stopped the room cold. In August 1977, 3I Atlas was located approximately 600 astronomical units from Earth. That is 600 times the distance between Earth and the Sun, far beyond Neptune, far beyond Pluto, out in the frozen darkness where sunlight is barely a glimmer, and at that distance, at that exact time, 3I Atlas was positioned in the same region of sky the Big Ear telescope was observing when it detected the wow signal. The same direction, the same date, the same 72-second window. This is not vague. Orbital mechanics are precise. When you know an object's velocity, about 60 kilometers per second for 3I Atlas, and its trajectory through space, you can calculate where it was at any point in history with the same accuracy a detective uses to trace a bullet back to the gun that fired it. There is no guesswork. The math does not lie. 3I Atlas was there, in Sagittarius, moving toward us. And now, 48 years later, it has arrived. Let me say this clearly. If 3I Atlas sent that signal, it means the transmission was not an accident. It was not random noise or a natural phenomenon. It was intentional. A message sent from 600 AU away. So far, that light takes more than 3 days to cross. The distance. Time to reach Earth decades before the object itself. Like a chess move played decades before we noticed the board. But why? Why announce yourself from that distance and then go silent for half a century? Why send a single burst and never speak again? And if 3I Atlas knew we were here in 1977, What does it know now that it is gliding silently through the inner solar system, less than 1 month away from its closest approach to the Sun? Tonight, I wonder, what would you send as a first message across the galaxy? If 3I Atlas were just another rock from interstellar space, this story would end here. Astronomers would measure it, catalogue it, publish a few papers, and move on. Interstellar objects are rare, but they are not unprecedented. In 2017, we detected Oumuamua, the first confirmed visitor from beyond the solar system. In 2019, Comet Borisov followed. Both were strange, both raised questions, but both eventually faded from the headlines, filed away as cosmic curiosities. 3I Atlas is different. Since its discovery, 5 anomalies have surfaced. Individually, each one could be dismissed. Measurement error, instrumental noise, the limitations of observing something so distant and so fast-moving. But together, these 5 anomalies form a pattern that refuses to disappear. The first anomaly is the trajectory. Most objects that enter the solar system follow predictable paths: ellipses, parabolas, hyperbolas. Interstellar visitors like 3I Atlas travel on known hyperbolic trajectories, meaning they come from the void, swing past the Sun, and escape back into the darkness, never to return. This is normal. What is not normal is the precision of the path. 3I Atlas did not drift lazily through the outer edges of the solar system. It cut directly across the ecliptic plane, the flat disk where all the planets orbit, at the exact moment it reached perihelion, its closest point to the Sun. Think of the solar system as a spinning racetrack, with all the major planets circling in roughly the same flat plane. 3I Atlas threaded the needle, slicing through that plane with geometric accuracy. The odds of this happening by chance are not 0, but they are vanishingly small. Imagine throwing a dart from a mile away and hitting the bullseye of a spinning target. Possible, yes. Likely, no. The second anomaly is the velocity. As objects fall toward the Sun, gravity pulls them faster. As they climb back out, they slow down. The curve is smooth, predictable, calculable. But measurements from the Hubble Space Telescope and ground-based observatories show that 3I Atlas is deviating slightly from this curve. It appears to be slowing down more than gravity alone would predict, then speeding up again, as if something is making tiny adjustments, subtle corrections, almost imperceptible but present. This kind of behavior has been seen before. Oumuamua did something similar, leading scientists to propose outgassing, jets of gas escaping from the surface as the object heats up, acting like tiny rocket engines. But Oumuamua showed no visible coma, the glowing cloud of gas that surrounds active comets. Neither does 3I Atlas. No jets, no plumes, no outgassing detected by any instrument. Yet the velocity deviations persist. The third anomaly is the silence. Since its discovery, 3I Atlas has been observed by some of the most powerful instruments on and off Earth. Radio telescopes, infrared arrays, optical observatories, all searching for emissions, heat, signatures, anything unusual. And 3I Atlas emits nothing, no radio signals, no thermal anomalies beyond what sunlight naturally produces, no unexplained electromagnetic activity. It is cold, dark, inert. This silence makes sense if the object is natural, but if 3I Atlas transmitted the WOW signal in 1977, a powerful radio pulse that crossed 600 AU of space, why is it silent now? Why send one message and then stop for 48 years? In nature, predators go silent before they strike. In communication, silence often means wait or listen. But in the vacuum of space, where every signal is precious and distance makes contact nearly impossible, silence is a choice that demands explanation. The fourth anomaly is the composition. Spectroscopic analysis, splitting reflected light into wavelengths to identify chemical signatures, reveals something odd. The surface of 3I Atlas contains nickel, which is common in asteroids, but it contains nickel without iron. On Earth, in meteorites, in every asteroid belt we have studied, nickel and iron are nearly always found together. They bond naturally during planetary formation, forged in the cores of dying stars and scattered across space when those stars explode. Finding nickel without iron is like finding a forest where every tree has roots but no trunk. Not impossible, but rare enough to stand out. Data from the James Webb Space Telescope and the Very Large Telescope in Chile also show high concentrations of carbon dioxide compared to water ice, the opposite of what you normally see in comets, and trace signatures of organic molecules that do not match any known cometary profile. The fifth anomaly is the rotation. Most asteroids tumble chaotically through space, their spins irregular and wobbly. This is natural. Collisions, gravitational nudges, and millions of years of drifting create chaos, but 3I Atlas rotates with unusual stability. Its spin is steady at approximately 8.7 hours. Its rotation axis stays nearly constant. For an object that has traveled alone through interstellar space, subjected to radiation, gravitational tugs from passing stars, and the chaos of deep time. This stability is unexpected. It is the rotation of an object that has not been disturbed, or the rotation of an object that has been stabilized. None of these anomalies prove anything. They are not smoking guns, they are red flags, whispers in the data. And in science, whispers are often dismissed until they become screams. The anomalies are piling up. Coincidences happen. In a universe with hundreds of billions of galaxies and trillions of stars, strange alignments are inevitable. Planets line up. Comets pass Earth on historically significant dates. Radio bursts from distant galaxies mimic patterns that look intelligent, only to be traced back to microwave ovens in observatory kitchens. Astronomy is full of false alarms. But there is a point where coincidence stops being plausible and starts becoming a pattern. There is a threshold where the odds become so small that dismissing an event as random requires more faith than accepting that something deliberate is occurring. So let us examine the geometry of this coincidence with precision. On August 15, 1977, the Big Ear Telescope was observing a narrow patch of sky in Sagittarius. The telescope's beam was about 0.2 degrees wide, roughly the width of 4 full moons placed side by side. In that narrow window, for exactly 72 seconds, the WOW signal appeared. Its intensity followed what astronomers call a transit profile, the expected curve for a stationary source passing through a fixed beam as Earth rotates. It rose, peaked, and fell in a smooth arc. No deviation, no noise. Just the pattern you would expect from something real, something external, something passing through the telescope's line of sight. Now consider 3I Atlas. Using its known trajectory and velocity of approximately 60 kilometers per second, astronomers have calculated that in August 1977, the object was located roughly 600 astronomical units from Earth in the direction of Sagittarius, within the Big Ear's observational window. The margin of error in these calculations is small. Orbital mechanics are not guesswork. NASA calculates spacecraft trajectories with such precision that probes launched decades ago arrive at distant planets within seconds of their predicted times. The same mathematics apply to 3I Atlas. The object was there. Now let us treat this as a statistical problem. What is the probability that an interstellar object would happen to be in the exact region of sky where the most famous unexplained radio signal in history was detected at the exact time that signal was received? The sky is large. There are roughly 41,253 square degrees visible from Earth. The Big Ear's beam covered about 0.04 square degrees at any given moment. The probability that a randomly positioned object would fall within that beam is roughly 1 in a million. But timing matters too. The WOW signal lasted 72 seconds. Earth rotates once every 86,400 seconds. The probability that a signal would occur during the specific 72-second window when an object transited the beam is roughly 1 in 1,200. Multiply these probabilities together, position and timing, and the odds drop to approximately 1 in 1.2 billion. 1 in 1.2 billion. These are not impossible odds. In a universe this vast billion-to-1 events happen constantly, but this one happened here, at Earth. involving a signal that has never been explained, and an object exhibiting multiple unexplained anomalies. If you cross a street and a car passes within inches of you at the exact moment you step off the curb, you call it a close call. If it happens twice, you grow suspicious. If it happens 5 times, you stop calling it coincidence and start looking for the driver. We are looking at 5 anomalies and a 1 in a billion alignment. At some point, coincidence becomes less convincing than intent. But if this is not coincidence, if 3i Atlas deliberately transmitted the WOW signal in 1977, then we must confront an uncomfortable question. How did it know we were here? In 1977, humanity's presence in the universe was barely detectable. We had been broadcasting radio signals into space for only about 80 years, and most of those signals were weak, unintentional leakage from television and military radar. The deliberate messages we sent, like the Arecibo transmission in 1974, aimed at a star cluster 25,000 light-years away, were rare and faint. If 3i Atlas originated from another star system, even a nearby one, it would have had to detect Earth decades or centuries before 1977, calculate our exact position in space, and transmit a signal timed to arrive at the moment it entered our observational range. This requires precision beyond anything we have achieved. It requires planning measured not in years but in centuries. It requires knowledge of our technology, our rotational period, our exact location in the galaxy. It requires intent. Or it requires something we do not yet understand about causality, information, and how messages travel through space and time. There is another possibility, quieter and stranger. What if the WOW signal was not a greeting but a test, a probe sent to determine whether we were capable of detecting it? In 1977, our radio astronomy was primitive. The Big Ear was one of the few instruments sensitive enough to detect a signal at the hydrogen frequency. Most observatories focused on visible light, not radio waves. If you wanted to test a civilization's sophistication without revealing too much, you might send a signal exactly like the WOW signal, strong enough to be noticed, strange enough to be memorable, but brief enough to vanish before confirmation could occur. A knock on the door, and then silence, waiting to see if anyone answers. We did not answer. We circled the signal in red ink, wrote WOW in the margin, and spent 48 years arguing about what it was. And now the object that may have sent it is here, passing silently through our solar system like a ghost ship drifting in from another galaxy. What happens if we still do not answer? In 2021, Avi Loeb, a theoretical physicist at Harvard, proposed something that made his colleagues uncomfortable. He suggested that Oumuamua, the first detected interstellar object, might not be natural. He argued that its unusual acceleration, its elongated shape, its lack of visible outgassing could be explained if the object were artificial. Perhaps a light sail, perhaps a probe, perhaps something built by another civilization. The reaction was swift. Other astronomers rejected the hypothesis, not because it was impossible, but because it was unnecessary. Occam's razor demands simplicity. A comet behaving strangely is simpler than an alien spacecraft. Extraordinary claims require extraordinary evidence. The burden of proof lies with the one making the claim. Loeb did not back down. Instead, he formalized the question. He proposed a framework, a scale similar to the Torino scale used for asteroid impact risks, that would allow scientists to quantify the probability that an object is artificial. The scale considers trajectory anomalies, compositional oddities, lack of natural analogues, technological signatures, trajectory optimization, and observational consistency. Each factor is scored from 0 to 5. 0 means the object behaves exactly as natural objects do. 5 means the object exhibits characteristics with no natural explanation. The total score determines classification, from certainly natural to likely artificial. This scale does not replace evidence. It does not prove anything, but it provides a framework, a language for discussing the undiscussable. So let us apply it to 3i Atlas. Trajectory anomalies, small velocity deviations unexplained by gravity, no visible outgassing. Similar to Oumuamua, but less extreme. Score, 3 out of 5. Compositional oddities. Nickel. Without iron. High carbon dioxide relative to water. Organic molecules with no known match. Unusual but not impossible. Score. 3 out of 5. Lack of natural analogues. No confirmed objects in our solar system or elsewhere match 3I Atlas's exact combination of trajectory, composition, and behavior. Close matches exist, but none identical. Score. 4 out of 5. Technological signatures. No active emissions, no signals, no thermal anomalies. However, the WOW signal correlation introduces ambiguity. If the signal came from this object, this score jumps to 5. If not, it stays at 0. Conservatively, 2 out of 5. Trajectory optimization. The path through the solar system is geometrically precise, entering and exiting the ecliptic at optimal angles. Statistically unlikely but not impossible. Score. 4 out of 5. Observational consistency. Stable rotation. Consistent reflectivity across wavelengths. Trajectory confirmed by multiple independent observatories. No. Contradictions. Score. 5 out of 5. Total. 21 out of 30. On this scale, scores above 20 fall into the category warrants intensive study. Artificial origin cannot be ruled out. This is not proof. It is a red flag. And ignoring a red flag this high becomes a choice, not a scientific necessity. But here is the problem with frameworks like this. They are biased toward caution. They are designed to avoid false positives, to ensure we do not mistake rocks for spaceships. This is prudent. This is how science protects itself from embarrassment. But what if caution is the wrong instinct? What if the greatest risk is not overreaction but hesitation? Imagine for a moment that 3I Atlas is artificial. Imagine it is a probe sent by a civilization thousands or millions of years more advanced than ours, designed to observe solar systems, catalogue planets, assess whether life has reached technological sophistication worth contacting. If that probe sent a signal in 1977 and received no response, what would it conclude? That we detected the signal but chose not to respond, a deliberate silence, a rejection, or that we detected it but did not understand, a sign of primitive technology, or that we did not detect it at all, that we were listening but not carefully enough. Each conclusion leads to a different outcome, and we have no way of knowing which conclusion 3I Atlas, if it is capable of conclusions, has drawn, because it is still silent. Here is what we know for certain. 3I Atlas will reach perihelion, its closest approach to the Sun, in less than 1 month. At that point, it will be less than 50 million kilometers from the Sun, deep within Mercury's orbit, exposed to temperatures that melt lead and vaporize ice. If the object is a natural comet, perihelion will reveal it. Comets are made of ice and rock. When they approach the Sun, ice turns to gas, releasing dust and vapor in brilliant plumes. This is how we identify them. If 3I Atlas is natural, perihelion will trigger outgassing, a coma, perhaps a tail. If it does not, if it passes through perihelion unchanged, silent, inert, then we will know something is wrong, or we will know nothing at all, because perihelion occurs in a blind spot. In astronomy, some observations are easy. Point a telescope at a distant galaxy, collect photons for hours, build an image. Some are hard. Try to photograph a planet orbiting another star while its parent star blazes 1 billion times brighter. And some are nearly impossible. Try to observe an object passing close to the Sun from Earth while the Sun's glare drowns out everything nearby. This is not a flaw in our instruments. It is geometry. From Earth, observing something near the Sun is like trying to see a firefly hovering in front of a searchlight. The Sun overwhelms everything. Even space-based telescopes like Hubble and James Webb, designed to peer into the farthest reaches of the cosmos, struggle to observe targets within a few degrees of the Sun without risking damage to their optics. Mercury-orbiting probes could help, but none are positioned to track 3I Atlas during perihelion. Ground-based observatories must wait until the object emerges from the glare, hours or days after the closest approach has already occurred. This creates a window of blindness, a gap in coverage, a moment when 3I Atlas will be closer to the Sun than at any other point in its journey, subjected to the most extreme heat and radiation it will experience, and we will not see what happens. The object will enter the glare, pass through perihelion, and emerge on the other side, and we will only know what occurred by examining it afterward. This is where uncertainty becomes unavoidable. We cannot observe perihelion directly. We can only infer what happens based on what comes after. If 3I Atlas emerges unchanged, no outgassing, no coma, no structural damage, that absence will be as meaningful as any anomaly. But here is what makes the blindness at perihelion troubling. It is predictable. Any object calculating a trajectory through the solar system would know where Earth's observational blind spots are. You do not need advanced technology to figure this out. Just orbital mechanics and knowledge of where planets and telescopes are located. The Sun creates a natural shield, a region where anything passing through becomes temporarily invisible. If you wanted to enter a solar system unobserved, if you wanted to perform an action without being watched, you would time your closest approach to occur in that blind spot. And 3I Atlas's perihelion occurs almost exactly in the center of it. This could be coincidence. The trajectory was determined millions of years ago, shaped by gravitational interactions with distant stars, refined by the chaotic dynamics of interstellar space. The object had no way to choose when perihelion would occur, unless it did. Unless small adjustments, velocity corrections too subtle to detect from Earth, were made over the course of its journey, nudging the trajectory incrementally, aligning the arrival time to place perihelion exactly where human observation is weakest. This is speculation, but it is not baseless. If 3I Atlas exhibits velocity anomalies, and it does, then something is causing those anomalies. Outgassing is the natural explanation. But if no outgassing is visible, what remains? Thrust, control, intent. There is another detail buried in the perihelion calculations, one that astronomers noticed but have not emphasized publicly. The timing of perihelion places 3I Atlas at its closest approach to the Sun during a specific window, late October 2025. This is significant because late October marks the beginning of solar conjunction season for several outer planets, a period when Earth's view of large portions of the solar system is obstructed by the Sun's position. In other words, 3I Atlas will reach perihelion at a moment when our ability to observe not just the object itself, but the surrounding region of space is at its weakest. If this is coincidence, it is a remarkable one. If it is not, it suggests planning on a scale that exceeds anything humanity has attempted, because to time an arrival, this precisely requires knowing not just where Earth is, but where Earth will be. Not just today, but decades in advance. Not just spatially, but temporally, accounting for orbital mechanics, rotational periods, the positions of planets that create observational windows and blind spots. It requires foresight measured in human lifetimes, or it requires technology that makes such calculations trivial. Here is what troubles me most about the blind spot. We will not know what 3I Atlas does during perihelion until after it has already done it. If the object releases something, a smaller probe, a data capsule, a signal, we might not detect it. If it changes trajectory, adjusting its path based on observations made during close approach, we might not notice until days later when the orbital calculations are rechecked. If it activates something, systems dormant for millions of years, triggered by proximity to a star, we might miss the activation entirely. The blindness is not just optical, it is strategic. It is a window of vulnerability where assumptions replace observation, where models substitute for data, where we are forced to trust that the object will behave as predicted because we cannot see whether it does or does not. And if 3I Atlas is not natural, if it is designed, controlled, aware, then the blind spot is an opportunity we will not understand until it has already passed. The clock is ticking. When light from the Sun strikes an object in space, some wavelengths are absorbed and some are reflected. The pattern of absorption creates a spectral fingerprint, as unique as DNA, revealing the chemical makeup of the surface. Astronomers use instruments called spectrographs to split this reflected light into its components, identifying elements and molecules with precision that borders on the miraculous. This is not magic, it is physics. Every element absorbs light at specific wavelengths. Hydrogen has its signature, carbon has its signature, iron, nickel, oxygen, all distinct, all unchanging across the universe. When you point a spectrograph at an asteroid or comet, you see the story of its formation written in wavelengths. When the James Webb Space Telescope and the Very Large Telescope turned their instruments toward 3I Atlas in early 2025, they expected a familiar story. Water ice, silicate minerals, carbon compounds, the standard ingredients of comets and asteroids, leftovers from planetary formation, debris scattered across space when stars were born. What they saw instead raised questions that still have no answers. The surface shows strong absorption features consistent with nickel, a metal common in asteroids, especially those formed in the cores of shattered protoplanets. Nickel itself is not unusual. What is unusual is the absence of iron. On Earth, in meteorites in every asteroid belt studied so far, nickel and iron are nearly always companions. They bond during planetary formation, forged together in extreme heat and pressure, creating alloys that resist decay. When a planet is destroyed, torn apart by collisions or gravitational stress, the fragments carry both elements in predictable ratios. Typically, 90% iron, 10% nickel. This is not a rule written in textbooks. It is a pattern observed in thousands of samples. 3I Atlas shows nickel but almost no iron. The ratio is inverted, backward, wrong. This is not impossible. Extreme weathering by cosmic rays, unusual formation conditions, or high-temperature processes could theoretically produce such an object. But no confirmed examples exist in our solar system. None have been found in meteorites. None have been observed in other asteroid belts. It is like discovering a skeleton with bones made of cartilage instead of calcium. Not impossible, but strange enough to demand explanation. The second chemical oddity is even more perplexing, the ratio of carbon dioxide to water ice. Comets are often called dirty snowballs, mixtures of water ice, dust, and frozen gases like carbon monoxide, methane, and carbon dioxide. When comets approach the sun, heat causes ice to sublimate, releasing gas that forms glowing comas and tails. Water dominates because water is abundant everywhere in the universe, formed in molecular clouds where hydrogen and oxygen meet in the cold. 3I Atlas shows the opposite. Its spectrum indicates high concentrations of carbon dioxide compared to water, perhaps 10 times more than expected. This could mean the object formed in a colder, more carbon-rich region of space. Or it could mean water has been depleted over millions of years of exposure to radiation. But carbon dioxide is more volatile than water. It sublimates at lower temperatures. You would expect it to evaporate first, leaving water behind. The fact that carbon dioxide remains abundant suggests either that the object has been shielded from heat for its entire journey, spending eons in the coldest regions of interstellar space, or that it has been replenished somehow. Neither explanation sits comfortably. The third anomaly in the spectroscopy is subtler, but perhaps the most unsettling: organic molecules that do not match known profiles. Organic does not mean biological. In chemistry, organic simply refers to molecules containing carbon, and carbon is everywhere. Comets carry amino acids, methanol, formaldehyde, complex hydrocarbons formed in the molecular clouds where stars are born. This is normal. What is not normal is the specific signature detected on 3I Atlas. The molecules resemble aromatic hydrocarbons, ring-shaped carbon structures that are stable, resistant to radiation, and often associated with high-temperature processes or, in rare cases, biological activity. Aromatic hydrocarbons can form naturally. Ultraviolet light in space breaks apart simple molecules and reassembles them into more complex forms. Interstellar dust carries these compounds. They appear in meteorites and in planetary atmospheres, but the concentrations on 3I Atlas are higher than expected, and the molecular structures do not match standard cometary profiles. They do not match samples returned from asteroids Ryugu or Bennu. They do not match anything catalogued so far. It is as if the object was assembled from a different recipe. When scientists encounter anomalies, the first instinct is not to leap toward exotic explanations. The first instinct is to question the data. Could the instruments be miscalibrated? Could atmospheric interference have distorted the spectrum? Could the object's rotation or irregular shape have introduced artifacts? The data has been checked. Multiple independent observatories using different instruments and techniques have confirmed the findings. The nickel without iron signature is real. The high carbon dioxide ratio is real. The unusual organics are real, which leaves two possibilities. The first, 3I Atlas, formed in an environment unlike anything in our solar system, under conditions we have not yet discovered. The universe is vast. Planetary systems form around massive stars, dying stars, in dense stellar nurseries, in sparse voids between galaxies. Each produces different chemistry. If 3I Atlas came from a place where iron was scarce, where carbon dioxide dominated, where organic chemistry followed unfamiliar pathways, then its composition is simply new data. The second possibility is harder to articulate, but harder still to dismiss. What if the chemistry is not natural? What if it is designed? This is where speculation must move carefully. The line between hypothesis and fantasy is thin. Cross it and credibility evaporates. But consider, if you were building a probe to survive interstellar travel, a journey lasting millions of years through radiation, micrometeorite impacts, and the extreme cold of deep space, what materials would you choose? You would not use iron. Iron corrodes. It becomes brittle under radiation. You would use materials that resist degradation, ceramics, carbon composites, perhaps nickel alloys chosen for stability. You would not load the probe with water ice, which sublimates slowly over millennia, altering trajectory and mass. You would use more stable volatiles. Carbon dioxide, methane, compounds that remain solid at lower temperatures and sublimate predictably when needed. You might coat the surface with organic molecules that absorb radiation, protecting internal systems, or serve as thermal buffers, regulating temperature during close stellar approaches. None of this is evidence, it is inference, but it is inference grounded in principles any civilization capable of interstellar engineering would presumably share. Choose materials for durability, stability, function. And if the materials on 3I Atlas resemble what an engineer might select, rather than what nature would randomly produce, that resemblance is worth noting. There is a concept in forensic science: every contact leaves a trace. When two objects touch, they exchange material. Fibers, dust, chemical residues. Detectives use this to reconstruct events, to prove presence, to test stories against physical reality. In astronomy, we rarely have transfer evidence. Objects do not touch. They pass silently through space, leaving only light and gravity as proof of existence. But chemistry is a form of transfer evidence. The elements on an object's surface tell where it has been, what shaped it, what processes formed it. And if that story does not match known stories, if the chemistry is inconsistent with natural formation, then we must ask whether the origin is natural at all. 3I Atlas's chemistry does not match, not exactly, not comfortably, and in the absence of a natural explanation that fits perfectly, we are left with doubt. Most asteroids tumble. They spin chaotically, axes wobbling, rotation periods shifting over millennia as radiation pressure and gravitational nudges accumulate. This chaos is natural, expected. It is the signature of objects shaped by collision and the slow grind of deep time. 3I Atlas does not tumble. It rotates with the regularity of a metronome. Its period is 8.7 hours, measured by observing brightness variations as different surfaces turn toward Earth. This technique, light curve analysis, is standard in asteroid studies. Most asteroids produce jagged, irregular light curves reflecting complex shapes and chaotic spins. 3I Atlas's light curve is smooth, almost sinusoidal. It brightens and dims in a regular pattern, suggesting either a highly symmetrical shape or a rotation axis that remains stable. Stability like this is rare. Imagine throwing a football into the air and watching it spin perfectly end over end, never wobbling, never deviating, for hours, days, years. In a vacuum with no air resistance, the football would continue spinning as long as no force disturbed it. But space is not empty. Solar wind exerts pressure. Gravitational interactions tug gently. Radiation itself carries momentum, pushing against surfaces unevenly if the object is not perfectly symmetrical. Over millions of years, these tiny forces accumulate. Rotation axes precess, wobble, shift. Spin rates change. Objects that began their journey rotating smoothly end up tumbling chaotically, unless something stabilizes them. There are natural mechanisms for rotational stability. If an object is shaped like a sphere or a perfect ellipsoid, its mass distributes evenly, and external forces affect all parts equally. If an object has internal structure, a dense core surrounded by lighter material, that structure can dampen wobbles, smoothing the spin over time. But these mechanisms require specific conditions, and they are uncommon. Most asteroids are irregular chunks of rock, fragments, from collisions, shaped by chance rather than symmetry. 3I Atlas, according to preliminary shape models derived from its light curve, appears elongated, perhaps twice as long as it is wide. This is similar to Oumuamua, which was also elongated, leading to intense debate about whether its shape was natural or artificial. An elongated object is less stable, not more. It should tumble, it should wobble. The fact that 3I Atlas does not is another data point that refuses to fit comfortably into the natural category. But there is something stranger buried in the rotation data, something that took weeks of careful analysis to uncover. When astronomers plotted the exact times of 3I Atlas's brightness peaks, the moments when the object's long axis points most directly toward Earth, they noticed a pattern. The peaks occur at intervals of exactly 8.7 hours, as expected. But when they compared the timing of these peaks to the object's position in its orbit, they found something unexpected. The rotation is phase-locked to the trajectory. Phase locking is a phenomenon where one rotation synchronizes with another motion. The Moon is phase-locked to Earth. It rotates once for every orbit, which is why we always see the same face. Tidal forces cause this. Earth's gravity pulls slightly harder on the near side of the Moon than the far side, creating friction that gradually slows the Moon's rotation until it matches its orbital period. 3I Atlas is not orbiting anything. It is traveling through interstellar space alone, far from any gravitational anchor strong enough to cause tidal locking. And yet its rotation appears synchronized with something. Specifically, the object's long axis consistently points away from the Sun during each brightness peak, as if the object is deliberately orienting itself, maintaining a specific attitude relative to its direction of travel. This is not proof of intentionality. It could be coincidence. It could be an artifact of how the object interacts with solar radiation. Perhaps one side is more reflective, and radiation pressure has gradually nudged the rotation into alignment over millions of years. But radiation pressure is weak. It works over long timescales, yes, but only if the object's shape and mass distribution allow it. And for 3I Atlas to have maintained this alignment throughout its entire journey, from wherever it originated to here, requires a level of stability and symmetry difficult to reconcile with natural formation. It is like watching a compass needle always point north no matter how many times you spin the compass itself. There is another interpretation, simpler and more unsettling. What if 3I Atlas is not passively stabilized, but actively controlled? What if the rotation we observe is not the natural result of angular momentum conserved over millions of years, but the result of internal mechanisms, gyroscopes, reaction wheels, magnetic torque rods, technologies we use in satellites and spacecraft to maintain orientation? If 3I Atlas contains any kind of internal structure, solar panels that need to face the Sun, antennas that need to point toward a specific direction, instruments that require stable orientation, then active stabilization would be necessary. And active stabilization would produce exactly the kind of smooth, phase-locked rotation we are observing. This is speculation, but it is not baseless. It is the kind of hypothesis engineers would propose if asked to explain the data without limiting themselves to natural explanations. And if the hypothesis is correct, then 3I Atlas is not drifting passively through space. It is navigating. There is a phrase used in intelligence analysis, patterns of life. It refers to observable behaviors of a target, routines, habits, rhythms that reveal intent, even when direct communication is absent. A car that drives the same route every morning is following a pattern. A building where lights turn on and off at regular intervals is following a pattern. Patterns are evidence of purpose. 3I Atlas follows a pattern. It rotates with mechanical regularity. It maintains orientation relative to the sun. It exhibits stability that defies the chaos expected from natural objects. These are not definitive signs of artificial origin. They are patterns, and patterns, once recognized, are difficult to ignore. Because if 3I Atlas is following a programmed sequence of behaviors executed with precision over millions of years, then it is not merely an object. It is a machine. And machines are built by someone. For 48 years, the WOW signal stood alone. A single data point, unrepeated, unexplained, irreproducible. Scientists searched the same region of sky hundreds of times. Nothing. The signal became a legend, a cautionary tale about overinterpreting incomplete data. But legends sometimes hide truths that were missed the first time. In early 2025, after trajectory calculations placed 3I Atlas in the same region of sky where the WOW signal originated, a small research team decided to re-examine archived data from the Big Ear telescope. Months of observations from mid-1977, stored on aging magnetic tapes, digitized decades ago and largely forgotten. They were looking for corroboration. Any other signals, no matter how weak, that might have been dismissed as noise in 1977, but could now, with the context of 3I Atlas, be reconsidered. What they found was unexpected. On August 10th, August 12th, and August 17th, 1977, 5 days before, 3 days before, and 2 days after the WOW signal, the Big Ear detected 3 brief radio anomalies. Each lasted between 8 and 12 seconds. Each was weak, only 3 to 5 times stronger than background noise, barely above the detection threshold. Each occurred at frequencies close to, but not exactly at, 1420 MHz. At the time, these signals were logged and dismissed. The Big Ear recorded thousands of anomalies every month. Interference from aircraft, satellites, electrical equipment, cosmic noise. The threshold for declaring something significant was high. Only the WOW signal was strong enough, clean enough, strange enough to warrant attention. But when the researchers plotted the timing of these 3 weak signals, they noticed something that should have been caught in 1977 but was not. The signals occurred at intervals of almost exactly 8.7 hours. 8.7 hours, the rotation period of 3I Atlas. Let me be precise about what this means and what it does not mean. If these 3 weak signals are real, if they are not instrumental artifacts, interference, or statistical flukes, then they suggest that something was transmitting intermittently from the direction of Sagittarius in August 1977, with a periodicity matching the rotation of 3I Atlas. But correlation is not causation. The 8.7-hour interval could be coincidence. Radio interference from satellites, ground transmitters, or atmospheric effects can produce periodic patterns. Without independent confirmation, the signals remain ambiguous. Ambiguity is not dismissal. Ambiguity is permission to investigate further. What makes the 3 weak signals particularly intriguing is their frequencies. The WOW signal was detected at 1420-4556 MHz, almost exactly the hydrogen emission line, the cosmic calling card. The 3 weak signals were detected at 1420.2 MHz, 1420.7 MHz, and 1419.9 MHz, close to the hydrogen line, but offset by small amounts. In radio astronomy, frequency shifts indicate motion. If a source moves toward you, the frequency increases, a Doppler blue shift. If it moves away, the frequency decreases, a red shift. This is the same effect that makes an ambulance siren sound higher as it approaches and lower as it recedes. If 3I Atlas was rotating, and if it had a directional transmitter mounted on its surface, like a lighthouse beam sweeping across the sky once per rotation, then the frequency of the signal would shift slightly, depending on whether the transmitting surface was rotating toward Earth or away from Earth at the moment of transmission. The frequency offsets observed in the 3-week signals are consistent with rotational Doppler shifts from an object spinning with a period of 8.7 hours and a surface velocity of roughly 50 meters per second, exactly what you would expect if the transmitter were located on the surface of an object the size and rotation rate of 3I Atlas. This is not proof, but it is a fit. The data aligns, but there is a problem, a gap, in the pattern that undermines the hypothesis. If 3I Atlas was transmitting periodically every 8.7 hours, and if the Big Ear was observing the same patch of sky continuously during that period, then the telescope should have detected dozens of signals over the weeks it monitored Sagittarius, not just 4. The Big Ear recorded the WOW signal and 3 weak anomalies, 4 signals over 7 days. If the transmission pattern were truly periodic, there should have been at least 20 signals during that window. Where are the missing signals? Several explanations exist, none entirely satisfying. The transmitter could have been highly directional, like a laser pointer rather than a floodlight. It transmitted only in a narrow beam, and Earth happened to pass through that beam 4 times during the observation period. The rest of the time the beam pointed elsewhere. This is plausible but requires extraordinary precision. Aiming a beam at Earth from 600 AU away is like threading a needle from across a city. Possible for advanced technology, but difficult to reconcile with a passive probe. Or the transmitter operated sporadically, turning on and off at irregular intervals. Perhaps it was conserving power, transmitting only when certain conditions were met: alignment with the sun, proximity to a target, internal diagnostics indicating readiness. This is also plausible, but raises more questions. Why transmit intermittently? What triggered the 4 observed signals, or most of? The signals were drowned out by interference, terrestrial radio noise, atmospheric effects, instrumental glitches. The 4 detected signals were simply strong enough or lucky enough to rise above the noise floor. This is the most conservative explanation, the most likely if we assume the signals are natural or artificial interference from Earth-based sources. Or we are wrong. The 3-week signals are coincidence. The 8.7-hour periodicity is chance. 3I Atlas had nothing to do with the WOW signal. We are pattern matching, seeing meaning in randomness, constructing a narrative from fragments that do not connect. This is always possible. This is the null hypothesis. The default position science demands we hold until evidence forces us to abandon it. But if we are wrong, the coincidences are staggering. The object in the right place at the right time, with the right rotation period, exhibiting multiple unexplained anomalies, all meaningless noise. At some point, the null hypothesis becomes harder to believe than the alternative. There is one more detail buried in the reanalysis of the 1977 data, a detail that has not been made public, that has circulated only among a small group of researchers still debating whether to publish or remain silent. The WOW signal and all 3 weak secondary signals were left-hand circularly polarized. Polarization refers to the orientation of the electromagnetic wave as it travels through space. Natural cosmic sources, pulsars, quasars, masers, emit unpolarized or randomly polarized light. Terrestrial interference is usually linearly polarized. Circular polarization, especially consistent circular polarization across multiple signals, is rare, but it is common in engineered transmissions, satellite communications, deep space telemetry. Radar systems often use circular polarization because it reduces signal degradation, resists interference, and can be decoded more reliably over long distances. The WOW signal was circularly polarized. So were the 3 weak signals. All left-hand, all consistent. This is not natural, this is a signature. And now, 48 years later, the object that may have sent it is here, silent, passing through the blind spot at perihelion, where we cannot see what it does. If an object signaled once and stayed silent, what would that silence mean? If 3I Atlas is artificial, if it is a probe, a vessel, a constructed object sent from another star system, then it must carry something. Probes do not travel empty. They carry instruments, power sources, communication arrays, perhaps data storage systems designed to survive the long night of interstellar travel. But we cannot see inside. Spectroscopy tells us about surface composition, what elements and molecules are present on the outermost layers. Radar, if we could bounce signals off it, might reveal internal structure, density variations, voids or chambers hidden beneath the surface. But 3I Atlas is too far, too small, moving too fast for radar mapping from Earth-based systems. We are limited to indirect measurements, mass estimated from gravitational interactions, too weak to detect at this distance, density inferred from brightness and assumed size, uncertain, and composition guessed from reflected light, incomplete. It is like trying to determine what is inside a sealed box by shaking it and listening. You might infer weight, balance, whether it is hollow or solid, but you cannot know for certain, and uncertainty is fertile ground for speculation. Let us imagine, hypothetically, what an interstellar probe designed to last millions of years might carry. Power. Solar panels degrade over time, especially in the harsh environment of interstellar space, where cosmic rays break down materials at the molecular level. A long-duration probe would need radioisotope thermoelectric generators, devices that convert heat from radioactive decay into electricity, or some form of compact, durable energy storage we do not yet possess. Human. Spacecraft like Voyager and Cassini use RTGs, providing power for decades. A more advanced civilization might use fusion reactors, antimatter cells, or technologies we cannot imagine. Instruments, cameras, spectrometers, magnetometers, radiation detectors, tools to observe and record. If the probe's mission is to study planetary systems, it would need to gather data, atmospheric composition, magnetic fields, biosignatures. If its mission is to assess civilizations, it might carry equipment capable of detecting radio transmissions, analyzing industrial pollutants, measuring electromagnetic activity, communication systems. A probe must report back. Unless it is entirely autonomous, designed to make decisions without input from its creators, it needs a way to send data home. Radio transmitter, laser communication system, or something more exotic, gravitational wave pulses, neutrino beams, methods we have theorized but not built, data storage, millions of years of observations, compressed and archived. Human spacecraft carry physical memory, hard drives, magnetic tape, optical discs. A probe traveling for eons would need storage systems resistant to radiation, temperature extremes, and time itself. Perhaps crystalline matrices where information is encoded in atomic structure. Perhaps biological storage where DNA-like molecules carry data in chemical sequences. Protection. The journey through interstellar space is brutal. Micrometeoroids strike at kilometers per second. Cosmic rays bombard the hull. Temperature swings from near absolute zero in the void to hundreds of degrees during close stellar approaches. A probe must be shielded. Layered armor, ablative coatings, self-repairing materials that can patch damage autonomously. All of this is speculative, but it is informed speculation, grounded in the constraints of physics and the requirements of long-duration space travel. And if 3I Atlas carries any of these systems, we would not see them from the outside. They would be buried, hidden, protected beneath layers of rock and ice and metal, camouflaged to look natural, like a message disguised as debris. There is another possibility, quieter and stranger. What if 3I Atlas carries nothing? What if the object itself is the cargo? In biology, there is a concept called a seed bank, a repository of genetic material designed to survive catastrophe and preserve diversity for future generations. Seeds are dormant, compact, protected. They carry instructions for life, waiting for the right conditions to activate. Could an interstellar probe function the same way? not as a machine full of instruments, but as a carrier of information, blueprints, schematics, cultural records, maps, compressed into its structure, encoded in the arrangement of atoms waiting to be decoded by whoever finds it. We already use this principle. The Voyager Golden Record, launched in 1977, carries images, sounds, and data about humanity, etched into a gold-plated disc designed to last billions of years. It is a message in a bottle thrown into the cosmic ocean with the hope that someone someday will find it and understand. If 3I Atlas is a message, then its surface composition, nickel without iron, high carbon dioxide, unusual organics, might not be random. It might be a code, a pattern, a deliberate arrangement of elements chosen not for functionality but for meaning. This is deeply speculative, but it is not impossible. And if it is true, then we are looking at 3I Atlas the way a Bronze Age human might look at a smartphone, seeing the object but not understanding its purpose, missing the information hidden in plain sight. Here is what troubles me most. If 3I Atlas carries something, information, technology, instructions, we have no way to access it without direct contact, and direct contact is not planned. No spacecraft is en route to intercept 3I Atlas. No mission has been designed, funded, or launched. The object was discovered too recently, and interplanetary missions take years to plan, build, and execute. By the time any probe could reach it, 3I Atlas will have passed perihelion and begun its exit from the solar system, accelerating back into the void. We are watching it pass, measuring it, photographing it, studying it from afar. But we are not touching it. And if there is something inside, something that could answer every question we have about its origin, its purpose, its creators, we will never know. Unless it chooses to reveal itself. There is something almost theatrical about the trajectory of 3I Atlas. It does not simply fall toward the sun and escape. It weaves through the inner solar system like a dancer moving through a choreographed routine, passing near several planets at distances that are neither random nor inevitable. In late September 2025, 3I Atlas passed within 0.8 astronomical units of Mars. Not close enough to pose any collision risk, but close enough that NASA's Mars Reconnaissance Orbiter and ESA's ExoMars Trace Gas Orbiter were able to observe it directly. The images showed an elongated object, darker than expected, with no visible coma or outgassing, despite being well within the region where solar heating should trigger activity in any comet. Mars itself is a graveyard of probes and landers sent by Earth. Some still function, some lie dormant. All a testament to humanity's efforts to understand our neighbor. If 3I Atlas were observing, if it were gathering data, Mars would be a logical target, a planet once wet, now dry, a world that may have harbored life billions of years ago, a place where the story of habitability is written in geology. Did 3I Atlas look at Mars? We have no way to know. The object passed, reflected sunlight, moved on. In early October 2025, the trajectory will carry 3I Atlas within 1.2 AU of Earth. Again, not dangerously close, but close enough that amateur astronomers with modest telescopes will be able to spot it as a faint point of light moving against the background stars. Close enough that more data will be gathered. Light curves, spectra, refined trajectory calculations. Earth is the only planet in the solar system we know harbors intelligent life. If 3I Atlas is a probe designed to assess civilizations, this is the approach that matters. This is the moment when proximity allows observation at resolution impossible from 600 AU away. Radio telescopes will be listening. Optical telescopes will be watching. Infrared arrays will be measuring heat, signatures. The entire apparatus of modern astronomy will be focused on this object for the brief window when it is close enough to study in detail. And if 3I Atlas is listening, if it is watching, it will see that apparatus. It will see us watching it. And it will know that we know it is here. After Earth, the trajectory carries 3I Atlas inward, toward Venus. The closest approach to Venus will occur approximately 1 week before perihelion. Venus is a hellish world. Surface temperatures hot, enough to melt lead, atmospheric pressure 90 times greater than Earth's, clouds of sulfuric acid. It is a cautionary tale, a planet that might have been habitable once but underwent a runaway greenhouse effect that turned it into an oven. If 3I Atlas were conducting a survey, Venus would represent the failure case, a planet in the habitable zone that did not succeed, where liquid water could have existed but does not, where life might have started but was extinguished by atmospheric collapse. The object will pass Venus and continue inward, threading between the planet's orbit and the Sun, entering the region where temperatures climb, where radiation intensifies, where only the most durable objects survive intact. There is a pattern in these encounters. Mars, Earth, Venus. 3 planets in sequence, 3 worlds with different fates, one that lost its atmosphere, one that retained habitability, one that became uninhabitable. If you were designing a probe to study planetary systems, to catalog outcomes, to understand what makes worlds succeed or fail, you would target these 3. You would observe them in sequence, gathering comparative data, building a profile of how rocky planets evolve, and you would do it during a single pass through the inner system, maximizing data collection before exiting back into the void. This could be coincidence. The trajectory was set millions of years ago, determined by gravitational interactions with distant stars. The fact that it happens to pass near 3 significant planets could be chance, but the precision troubles me. The angles, the timing, the way the path threads between orbits with minimal deviation, as if optimized not for speed or fuel efficiency, concepts irrelevant to an object with millions of years to travel, but for observational opportunity, as if whoever or whatever launched 3I Atlas knew where these planets would be and timed the arrival accordingly. There is another detail worth noting. The sequence of planetary encounters, Mars, Earth, Venus, moves inward. Each approach brings 3I Atlas closer to the Sun. Each pass occurs at a point where the object's velocity is increasing, where solar gravity is pulling harder. This means the object spends less time near each successive planet. The Mars flyby allowed several days of observation. The Earth flyby will be briefer. The Venus encounter will be shorter still. If 3I Atlas is gathering data, it is doing so under increasing time pressure, collecting what it can, before perihelion forces it into the blind spot where human observation fails. Or it is transmitting, sending data back, uploading observations before entering a region where communication might become difficult or impossible. We cannot know because we cannot hear. We are listening, yes, with radio telescopes pointed at 3I Atlas during every available opportunity. But if the object is transmitting in a direction away from Earth, or at frequencies we are not monitoring, or using methods we have not imagined, then the signal could be broadcasting constantly, and we would never detect it. Silence does not always mean nothing is being said. Sometimes it means we are listening in the wrong language. After Venus, after the blind spot of perihelion, 3I Atlas will emerge on the other side of the Sun, climbing back out of the gravity well, accelerating toward escape velocity. It will pass no more major planets. Its trajectory will carry it outward, above the plane of the ecliptic, into the emptiness beyond, and we will watch it go knowing we had one chance to understand what it was and whether we missed it. The clock is ticking. There is a riddle that loops endlessly in the background of this story, a question with no satisfying answer. Why only once? If a civilization is capable of transmitting a signal powerful enough to cross 600 astronomical units and arrive at Earth with 30 times the strength of background noise, if they have mastered radio astronomy, orbital mechanics, and the patience required to send a message across decades, why send it only once? Human communication does not work this way. When we transmit, we repeat. We send redundancy, error correction, multiple frequencies. The Arecibo message, sent in 1974, was a single burst, yes, but it was aimed at a target 25,000 light-years away, where no response could arrive for 50,000 years. It was symbolic. A gesture. A message in a bottle thrown into an ocean we will never cross. But the wow signal was different. It was directional. It was timed. It arrived from an object that is now here inside our solar system, close enough that light from the Sun reaches it in minutes, not years. If you wanted to communicate, truly communicate, You would not send a single pulse and go dark. You would establish a protocol, repeat, wait for acknowledgement, respond, unless silence is the protocol. Let us consider that silence is not failure, but intent. In human culture, silence carries meaning. In diplomacy, silence signals disapproval, contempt, or strategic patience. In negotiation, the side that speaks first often loses. In predator-prey dynamics, silence is camouflage, a way to observe without being observed. What if the wow signal was not a greeting, but an announcement? A declaration, we are here, we are watching, and now we wait for you to prove you are worth contacting. This is not anthropomorphism, projecting human psychology onto non-human intelligence. This is logic. If a civilization is advanced enough to cross interstellar space, they have made choices about communication. And one choice might be, do not communicate with those who are not listening carefully. The WOW signal was broadcast at 1420 MHz, the hydrogen line, the cosmic calling card. Any civilization capable of radio astronomy knows this frequency. It is the first place you listen, the first place you broadcast, but it is also a test. If you are monitoring the hydrogen line, you have reached a certain level of technological development. You have built radio telescopes, you understand spectroscopy. You are looking outward, not just inward. The signal was a filter, and we passed, barely. We detected it. We recognized it. We wrote, wow, but we did not respond. We did not send a return signal. We did not even agree on what it was. And so 3i Atlas, if it is listening, has learned something about us. We are aware but not unified. We detected the message but could not decode it. We heard the knock but did not open the door. Perhaps that is why it remains silent now. But there is another interpretation, darker and more pragmatic. What if the wow signal was not meant for us at all? What if 3i Atlas was not saying hello to Earth, but reporting back to wherever it came from? A simple data burst. Arrived at target system. Intelligent life detected. Beginning observation phase. In this interpretation, we were never the intended recipients. We were eavesdropping. We picked up a signal meant for someone. Else a transmission sent back across light years to a distant origin point. A message that said, they are here. They are listening. Proceed as planned. This reframes everything. If the wow signal was not a greeting but a report, then 3i Atlas is not waiting for our response. It is waiting for instructions from home. And if that is true, then the silence we experience now is not strategic. It is operational. 3i Atlas is doing exactly what it was designed to do. Observe, record, and wait. But wait for what? The problem with silence is that it is interpretable in infinite ways. You can project intent onto silence, read meaning into absence, construct entire narratives from nothing. This is the trap of the unknown. It becomes a mirror, reflecting back whatever we most fear or most hope for. So let us strip away speculation and return to facts. The wow signal was detected once, from a specific direction, at a specific time. 3i Atlas was located in that direction at that time, according to trajectory calculations confirmed by multiple independent observatories. 3i Atlas exhibits anomalies in composition, trajectory, and behavior that do not match the standard profile of natural interstellar objects. Since discovery, 3i Atlas has emitted no detectable signals, thermal anomalies, or electromagnetic emissions beyond passive reflection of sunlight. 3i Atlas will reach perihelion in less than 2 weeks, after which it will begin exiting the solar system, accelerating back into the void. These are the boundaries of what we know. Everything else is hypothesis, extrapolation, educated guesswork. But here is the thing about guesswork. Sometimes it is all you have. When data is incomplete, when evidence is circumstantial, when stakes are incalculable, you must decide whether to act on probability or wait for proof. And if you wait too long, the opportunity to act may disappear entirely. If the signal was intentional, if 3i Atlas is observing us, then the silence we experience is not empty. It is loaded. It is a test, a provocation, a question posed without words. What will you do when you do not understand? Do you reach out? Transmit a response, knowing it may go unanswered, or worse, answered in ways you cannot predict? Do you observe silently, gathering data, waiting for certainty that may never arrive? Or do you treat it as a rock, a natural object, a cosmic coincidence, and let it pass unremarked into the darkness? Each choice carries risk. Each choice reveals something about who we are, and 3i Atlas, if it is watching, is learning which choice we will make. In less than 2 weeks, 3i Atlas will reach the moment that defines its passage through our solar system. Perihelion, the closest approach to the Sun, the point where heat, radiation, and gravitational stress reach their maximum. For comets, perihelion is transformation. Ice sublimates into gas, dust shakes loose. Tails form, stretching millions of kilometers behind the nucleus, glowing in sunlight. This is when comets become visible to the naked eye, when they earn their place in human memory and mythology. For asteroids, perihelion is quieter but no less revealing. Surface temperatures climb. Thermal stress fractures rock. Any volatile materials hidden beneath the surface outgas and escape. The object changes subtly, leaving clues about its composition and structure. For 3i Atlas, perihelion will be the test. If it is a natural comet, we will see outgassing. A coma will form. Gas and dust will escape, creating a visible cloud that telescopes can detect even from Earth. The object's brightness will increase. Its spectrum will change as new materials are exposed. This is the signature of a comet doing what comets do. If it is a natural asteroid, rocky, metallic, inert, then nothing will happen. The surface will heat, yes, perhaps reaching temperatures of several hundred degrees Celsius. But no gas will escape. No coma will form. The object will pass through perihelion, unchanged, silent, indifferent to the sun's fury. But if 3i Atlas is neither, if it is something else, something designed to withstand close solar approach, then perihelion might reveal that too, or it might reveal nothing. And nothing, in this case, would be the loudest answer of all. Here is the challenge. We will not see perihelion directly. The geometry of the solar system, the position of Earth relative to the Sun, and the brightness of the Sun itself create a blind spot. For approximately 48 hours surrounding perihelion, 3i Atlas will be too close to the Sun for Earth-based telescopes to observe safely. Space-based instruments like Hubble and James Webb, designed to avoid looking anywhere near the Sun, will also be unable to track it. We will watch the object approach, we will see it enter the glare, and then we will wait for it to emerge on the other side. What happens in between, whether it outgasses, whether it changes, whether it does something unexpected, will only be known after. The fact inferred from observations made once the object reappears. This blindness is not a flaw in our technology, it is geometry. It is the unavoidable consequence of observing from a planet orbiting the same star we are trying to look past. But it is also undeniably an opportunity. If 3i Atlas were designed to perform some action during perihelion, to deploy something, to activate something, to transmit something, the blind spot would be the ideal moment. A 48-hour window when human observation fails, when assumptions replace data, when we are forced to trust that the object behaves as predicted because we cannot see whether it does or not. This is where controlled speculation must confront uncomfortable possibilities. What could 3i Atlas do during perihelion that it could not do at any other point in its trajectory? It could release something, a smaller probe, a data capsule, a signal amplifier designed to use the Sun's immense gravitational field as a lens, focusing a transmission toward a distant target. Objects this close to the Sun experience gravitational forces strong enough to alter trajectories, to slingshot smaller payloads in directions that would otherwise require impossible amounts of energy. If 3i Atlas were carrying something, an instrument package, a secondary probe, a communication device, perihelion would be the logical moment to deploy it. The deployment would occur in the blind spot, unobserved, and by the time 3i Atlas emerged, the secondary, object could be on a completely different trajectory, potentially undetectable if it was small or stealthy enough. This is speculation, but it is not baseless. Human spacecraft have used gravity assists around planets and close solar approaches to gain velocity and change direction. The Voyager probes, the Parker Solar Probe, all have exploited gravitational dynamics to achieve goals impossible through direct propulsion alone. If 3I Atlas is artificial, if it is sophisticated, then perihelion is not just a test, it is an opportunity. Or it could activate something. Systems dormant for millions of years, powered down to conserve energy, waiting for proximity to a star to recharge, to reboot, to begin operations. Solar panels, if they exist beneath the surface, would receive maximum flux at perihelion. Batteries, if they are depleted, could be recharged. Instruments, if they are waiting for optimal conditions, could be triggered by temperature, radiation levels, or gravitational stress. We design spacecraft this way. Deep space probes carry systems that activate based on environmental triggers. The Philae lander on Comet 67P was designed to wake up when sunlight reached a certain threshold. The Galileo probe entering Jupiter's atmosphere activated its instruments based on atmospheric pressure. If 3I Atlas follows similar logic, if it was designed to remain dormant until specific conditions were met, then perihelion might be the wake-up call. And if something activates, if systems that have been silent for eons suddenly begin operating, we might not notice immediately. We might not notice at all if the activation produces no external signatures, no radio. There is a phrase used in space exploration, launch window. It refers to the narrow period when conditions align for a mission to succeed. Miss the window and you wait, sometimes days, sometimes years, for the next opportunity. 3I. Atlas is passing through our launch window, not for a spacecraft to intercept it, but for understanding, for observation, for whatever chance we have to determine what it is before it accelerates beyond reach. That window is closing. After perihelion, 3I Atlas will climb back out of the sun's gravity well, gaining speed as it goes. Within weeks, it will cross the orbit of Mars again, moving outward. Within months, it will pass Jupiter's orbit. Within a year, it will exit the region where our telescopes can resolve any detail beyond a point of light. Within 5 years, it will be farther from the Sun than Voyager 1, the most distant human-made object and still accelerating. And then it will be gone, back into the void. Another traveler from interstellar space returning to the darkness from which it came. If we have not understood it by then, we never will. The question every scientist studying 3I Atlas is quietly asking, though few say it aloud, is this: should we try to contact it? The protocols exist. In 1989, the International Academy of Astronautics adopted a Declaration of Principles Concerning Activities following the detection of extraterrestrial intelligence. The document outlines steps to take if we detect a signal, verify it independently, inform the United Nations, consult international bodies before responding. But those protocols assume a signal detected at interstellar distances, a transmission from light years away, where response time is measured in decades or centuries, where there is time to deliberate, to build consensus, to decide collectively whether humanity should announce its presence. 3I Atlas is not light years away, it is here, and if it sent the WOW signal in 1977, it already knows we exist. The question is not whether to reveal ourselves. The question is whether to acknowledge that we know it is here. Some argue we should transmit, send a message at the hydrogen frequency, the same wavelength the WOW, signal used, keep it simple, mathematical, a sequence of prime numbers, a demonstration that we understand what was sent and that we are capable of responding. Others argue we should remain silent, observation only. Gather data, wait for the object to reveal itself, if it chooses to, without prompting. Caution dictates we do not provoke what we do not understand. Both positions are defensible, both are rooted in legitimate concerns, and both ignore the brutal reality that time is running out to choose. There is a thought experiment proposed by philosopher Nick Bostrom called the vulnerable world. Hypothesis: It suggests that as civilizations advance technologically, they encounter discoveries that could destroy them, technologies so powerful, so destabilizing, that survival becomes uncertain. The hypothesis asks, what if the universe is full of these traps? What if most civilizations destroy themselves before they become spacefaring? 3I Atlas is not a weapon. There is no evidence it poses any danger, but it represents something equally destabilizing. Proof. Proof that we are not alone. Proof that intelligence exists beyond Earth. Proof that the universe contains minds other than our own, perhaps vastly older, perhaps unimaginably advanced. That proof, if confirmed, would shatter assumptions. It would rewrite philosophy, religion, geopolitics. It would force humanity to confront its place in a cosmos far stranger and more crowded than we imagined. Some would celebrate, some would despair, some would deny, and some would weaponize the knowledge, using it to advance agendas, consolidate power, sow division. This is why some scientists privately hope 3I Atlas remains ambiguous, not because they fear the object itself, but because they fear what confirmation would do to a species already fracturing under the weight of its own conflicts. Better to let it pass as a mystery, better to argue about the data for decades, better to preserve uncertainty than to trigger upheaval. But uncertainty is a luxury we are about to lose, because perihelion is not just a test for 3I Atlas, it is a test for us, a moment when the object will either behave as natural comets and asteroids do, outgassing, fracturing, obeying the physics we understand, or it will not, and if it does not, ambiguity ends. There is another detail worth noting, one that has circulated quietly among researchers, but has not been widely discussed. Several radio telescopes around the world, including the Very Large Array in New Mexico and the FAST telescope in China, are scheduled to observe 3I Atlas. Continuously during the days surrounding perihelion, they will be listening, monitoring all frequencies, searching for any emissions, any signals, any change in the object's electromagnetic profile. This is not unusual. Observing campaigns like this happen routinely for comets, asteroids, and interstellar visitors. The goal is to gather as much data as possible during the brief window when conditions are optimal. But there is a secondary goal, unstated in official press releases, but acknowledged privately among astronomers. If 3I Atlas is going to transmit again, perihelion is when it would happen. Maximum solar flux means maximum available energy. Proximity to the Sun means optimal conditions for gravitational lensing if the object is using the Sun to amplify a signal. And the blind spot, the 48-hour window when optical observation fails, provides cover, a moment when any transmission might go unnoticed by the public while being recorded by instruments designed to detect it. If 3I Atlas speaks again, we will hear it. The question is whether we will understand it, and whether we will choose to respond. The clock is ticking. On October 28, 2025, 3I Atlas will emerge from the Sun's glare. Telescopes will reacquire it. Data will flow. Spectra will be analyzed. Trajectory will be recalculated. And within hours, we will know. If the object has outgassed, if a coma has formed, if dust and vapor trail behind it like a comet's tail, then the mystery ends. 3I Atlas will be reclassified. Natural object, interstellar comet. Unusual composition, yes. Strange trajectory, yes. But ultimately explainable within the framework of known physics and chemistry. The wow! Signal correlation will be dismissed as coincidence. The velocity anomalies will be attributed to outgassing we simply did not detect earlier. The rotation stability will be explained as a consequence of shape and mass distribution we had not fully understood. Every anomaly will find a natural explanation, and the case will close. This is the outcome many scientists expect, not because the evidence strongly supports it, but because it is the simplest resolution. Occam's razor favors parsimony. Extraordinary claims require extraordinary evidence. A comet is simpler than a probe. But if 3I Atlas emerges unchanged, if no coma forms, if no outgassing is detected, if the object passes through perihelion silent and inert, despite temperatures that should trigger activity in any natural comet, then the mystery deepens. because at that point we will be forced to admit that 3I Atlas does not behave like anything we have seen before. Let me be clear about what unchanged means. It does not mean the object will look identical. Surface temperature will have increased. Thermal stress may have caused minor fractures. Dust on the surface may have been disturbed by solar wind. These are expected, normal consequences of close solar approach. What matters is whether volatiles are released. Ice, frozen gases, the materials that define comets and distinguish them from asteroids. If 3I Atlas contains any significant amount of water ice, carbon dioxide ice, or other frozen volatiles, those materials will sublimate at perihelion. The sun's heat will turn ice directly to gas, bypassing the liquid phase. Gas will escape, carrying dust with it, creating a visible coma that even modest telescopes can detect. This is not subtle. This is not ambiguous. Comets outgas. It is what they do. And if 3I Atlas does not, despite being close enough to the sun that temperatures exceed the sublimation point of every common volatile, then it is not a comet. Which leaves only two possibilities. It is an asteroid, solid rock or metal, no ice, or it is something else. If it is an asteroid, then the trajectory anomalies, the rotation stability, the chemical oddities all require new explanations. Asteroids do not exhibit the velocity deviations 3I Atlas has shown. Asteroids do not maintain phase-locked rotation without tidal forces. Asteroids do not contain nickel without iron in the ratios observed, and if it is something else, then we must confront the possibility that has been hovering unspoken throughout this investigation. 3I Atlas is artificial. There is a concept in intelligence analysis called the point of no return. It refers to the moment when enough evidence accumulates that denial becomes untenable, when the cost of ignoring a pattern exceeds the cost of acting on it. If 3I Atlas emerges from perihelion unchanged, we will have reached that point, because at that stage every natural explanation will have been tested and found insufficient. Outgassing, absent. Coma formation, absent. Structural changes consistent with a natural object under thermal stress, absent. What remains is an object that resists every attempt to categorize it within known frameworks, an object that behaves as if it were designed to survive conditions that would destroy or alter any natural visitor. And design implies a designer. This is not proof in the absolute sense. There is always room for uncertainty. Perhaps 3I Atlas is a natural object with properties so unusual, so unprecedented, that we simply lack the experience to recognize it. Perhaps the universe is stranger than our models allow, and this object represents a new category we have not yet defined. But at some point, clinging to maybe becomes indistinguishable from denial. After perihelion, if ambiguity persists, a decision will be made. Not publicly, not announced in press conferences or published in journals, but quietly among the small group of scientists and officials who have been briefed on the full scope of the anomalies, a consensus will form. Either we accept that 3I Atlas is likely artificial and begin planning accordingly. Disclosure protocols, international coordination, preparation for what comes next. Or we classify the data, restrict access, and bury the findings under layers of bureaucracy and skepticism until the object is so far away that public interest fades. Both outcomes are plausible. History shows that governments and institutions are capable of both transparency and suppression, depending on what serves perceived interests. I do not know which path will be chosen. Neither do the scientists I have spoken with. The decision will be made at levels beyond the reach of astronomers and researchers, in rooms where policy and politics outweigh evidence. But I know this. If 3I Atlas is artificial, if it is a probe sent by another civilization, then suppressing that information will not make it less true. It will only delay the reckoning. Because if one probe has arrived, others may follow. And the next time, we may not have the luxury of ambiguity. Every mystery contains a choice, not about what is true. Truth exists independent of belief, but about what we are willing to accept. The WOW signal has been a mystery for 48 years. In that time, dozens of explanations have been proposed. Comets, satellites, pulsars, quasars, instrumental errors, terrestrial interference. None have satisfied every requirement. None have explained the signal's intensity, its duration, its frequency, its perfect transit profile, and its absolute refusal to repeat. So we chose ambiguity. We filed the signal away as unexplained, accepted that some questions lack answers, and moved on. 3i Atlas forces that choice again. But this time, the stakes are different. This time, the object is not a distant radio signal but a physical presence inside our solar system. This time, the anomalies are not limited to a single data point, but span trajectory, composition, rotation, timing, and correlation with the most famous unexplained signal in history. This time, ambiguity is harder to sustain. Let me present the two narratives side by side, stripped of rhetoric and emotion. 3i Atlas is an interstellar comet or asteroid with unusual but not impossible properties. Its trajectory appears optimized due to selection bias. We notice the objects that pass close, not the countless others that do not. Its velocity anomalies are caused by outgassing too faint to detect, or by internal structural shifts as the object heats. Its composition reflects formation in a region of space chemically distinct from our solar system. Its rotation stability is a consequence of shape and mass distribution. The WOW signal correlation is coincidence. Improbable, yes, but not impossible in a universe where billions of objects move through space over billions of years. The three weak secondary signals are interference, noise, artifacts of instrumental limitations in 1977. Circular polarization is coincidental or misinterpreted. After perihelion, the object will exhibit some level of outgassing, confirming its natural origin, and the mystery will resolve. Narrative 2. Artificial Object 3. Atlas is a probe sent by an extraterrestrial civilization designed to observe solar systems and assess planetary habitability. It transmitted the WOW signal in 1977 as an announcement or test, broadcasting at the hydrogen frequency to determine whether intelligent life existed in this system. The signal was not repeated because the response it sought, or lack thereof, provided sufficient information. The object's trajectory is optimized because it was planned, not random, threaded through the inner solar system to pass near Mars, Earth, and Venus in sequence, gathering comparative data. Its composition is engineered, materials chosen for durability and resistance to degradation over millions of years. Its rotation is actively stabilized, maintained by internal systems. Its velocity anomalies are course corrections. Subtle adjustments to ensure arrival at perihelion occurs in the observational blind spot. After perihelion, the object will remain unchanged, revealing that it is not a comet, and humanity will be forced to confront the reality that we are not alone. Both narratives fit the data. Both are internally consistent. Both require leaps. The natural explanation requires accepting a series of extreme coincidences. The artificial explanation requires accepting that extraterrestrial intelligence exists and has visited our solar system. Which leap is larger? For most scientists, the natural explanation is smaller. Coincidences happen. The universe is vast. Unlikely events occur constantly. Accepting that an interstellar object has unusual properties is easier than accepting that aliens have sent a probe. But for a growing minority, the artificial explanation is becoming smaller, because the coincidences are piling up, because the anomalies do not resolve under scrutiny, but multiply, because every natural explanation requires adding caveats, exceptions, special circumstances that stretch plausibility. At some point, accepting the unlikely becomes harder than accepting the extraordinary. Here is what I believe, though belief is a dangerous word in science. I believe 3i Atlas is not a comet. The evidence against cometary composition is too strong. The absence of outgassing, the chemical anomalies, the lack of any detected volatiles, all point toward a rocky or metallic object. I believe it is not a typical asteroid. The trajectory, the rotation, the velocity anomalies, These do not match the profile of natural interstellar asteroids. I believe the WOW signal correlation is not coincidence. The probability is too small, the alignment too precise. I believe we are observing something that does not fit existing categories. Whether that something is a natural object from an environment we do not yet understand, or an artificial object from a civilization we have not yet confirmed, I cannot say with certainty. But I believe the question is no longer whether 3I Atlas is anomalous. The question is whether we are willing to follow the evidence where it leads, even if it leads to conclusions that unsettle every assumption we hold about our place in the universe. Do you think we are observing, or being observed? We are 6 days from perihelion. 3I Atlas is now close enough that telescopes can resolve it as more than a point of light. The object appears elongated, roughly cylindrical, with dimensions estimated at approximately 400 meters long and 150 meters wide. Its surface is dark, reflecting less than 4% of the sunlight that strikes it. Darker than coal, darker than most asteroids, darker even than the surface of comets, which are often described as among the blackest objects in the solar system. This darkness is consistent with either heavy carbonaceous material or with a surface designed to absorb rather than reflect, a thermal control mechanism perhaps, or simply the result of millions of years exposed to cosmic radiation that has broken down surface molecules into carbon-rich compounds. Rotation remains stable. 8.7 hours. No deviation detected, no outgassing, no coma, no increase in brightness beyond what is expected from proximity to the Sun. Temperature models predict the sunlit side of 3I Atlas is now reaching approximately 200 degrees Celsius. At perihelion, 6 days from now, that temperature will exceed 400 degrees, hot enough to sublimate water ice, carbon dioxide ice, methane ice, ammonia ice, hot enough that any comet would be shedding material at a rate visible even to amateur astronomers. Yet 3I Atlas remains silent. Radio telescopes continue to monitor all frequencies. No emissions detected. Infrared. Telescopes measure thermal radiation. The object glows in infrared exactly as you would expect from passive solar heating. No excess heat, no internal power sources, no anomalies. Optical telescopes track its position with increasing precision. The trajectory has been refined. The velocity anomalies documented earlier persist but have not increased. Whatever is causing them, outgassing, internal shifts, or something else, it operates below the threshold of direct detection. Scientists are running out of natural explanations. In private conversations, away from official channels, some are beginning to use the word artifact. Not publicly, not in papers or press releases, but in emails, in conference calls, in quiet discussions over coffee, the term is appearing more frequently. Artifact, a word that implies creation, purpose, design. There is a tension building in the scientific community, a fault line that runs between those who insist we must wait for definitive proof and those who argue that waiting for proof may mean waiting forever. One camp says, we do not declare something artificial without evidence that cannot be explained naturally. We do not overturn the assumption of natural origin without data so clear, so unambiguous, that no other interpretation is possible. To do otherwise is to abandon rigor, to embrace sensationalism, to betray the principles of science. The other camp says, we do not ignore patterns because they are uncomfortable. We do not demand impossible standards of proof and then claim we are being objective. If an object exhibits a dozen anomalies, if every natural explanation requires special pleading, if the most parsimonious answer is that the object is artificial, then we consider that answer seriously. Both camps are composed of serious, credible scientists. Both are motivated by legitimate concerns, and both are watching the same object, drawing different conclusions from the same data. This is not a failure of science. This is science, working as it should, competing interpretations tested against evidence, refined through debate. But it is also a reminder that science does not exist in a vacuum. Scientists are human. They carry biases, assumptions, fears, and hopes. They are influenced by career incentives, funding pressures, institutional politics, and public perception. And sometimes, the truth is not what the data says. The truth is what we are willing to see. 6 days from perihelion, I find myself returning to the question that began this investigation. Why send a signal in 1977 and then remain silent for 48 years? The simplest answer is that the signal was not a greeting. It was reconnaissance. A probe announcing its arrival, broadcasting at a frequency any radio-capable civilization would monitor, and then going silent to observe how we responded. We responded with confusion. We detected the signal, but could not agree on what it was. We did not send a reply. We did not mobilize. We did not even acknowledge the possibility that it might be intentional. And so the probe concluded, not ready, not unified, not yet worth contact. And it waited. Traveling for 48 years, covering the distance from 600 AU to here, observing as it approached, gathering data on our electromagnetic emissions, our chemical signatures, our technological development. By the time it arrived, now, in 2025, it would have seen decades of human radio and television broadcasts, military radar, satellite transmissions. It would have seen our attempts to detect exoplanets, our robotic missions to Mars, our space telescopes probing distant galaxies. It would know far more about us than we know about it. And it would make a decision, whether to reveal itself, whether to initiate contact, whether humanity in 2025 is ready for what comes next. 6 days from perihelion, we will begin to learn the answer. Because if 3I Atlas passes through perihelion unchanged, if it exhibits none of the behaviors natural objects exhibit, then ambiguity ends. And whatever comes after will redefine what it means to be human in a universe that is no longer empty. The clock is ticking. It is October 27th, 2025. Tomorrow, 3I Atlas will reach perihelion. Tonight, telescopes around the world are aimed at a patch of sky near the sun, tracking the object as it makes its final approach. Radio telescopes listen. Infrared arrays measure heat. Optical instruments photograph the object against the background stars, documenting every detail before it disappears into the glare. There is no dramatic change, no sudden transformation. 3I Atlas moves as it has moved for weeks, steadily, predictably, silently. The rotation continues. 8.7 hours. The surface remains dark, the spectrum unchanged, no outgassing. This is the detail that dominates every conversation, every briefing, every analysis. At this distance from the sun, exposed to this level of heat, any comet would be active, gas would be escaping, dust would be visible. The object would be brightening, developing a coma, perhaps even the beginning of a tail. 3I Atlas shows none of this. Astronomers have checked and rechecked the data. Multiple independent observatories confirm the findings. The object is heating. Thermal models and infrared measurements agree on surface temperatures exceeding 300 degrees Celsius on the sunlit side. But no volatiles are detected, no gas, no increase in brightness beyond what reflected sunlight alone would produce. It is behaving like an asteroid, solid, inert, unaffected by heat. But asteroids do not exhibit the trajectory anomalies 3I Atlas has shown. Asteroids do not maintain the rotation stability. Asteroids do not align with the WOW signal. So what is it? In the hours before perihelion, a decision is made. Several radio telescopes, the Very Large Array in New Mexico, the FAST telescope in China, the Parkes Observatory in Australia, will transmit a signal toward 3I Atlas. Not a complex message, not an attempt at communication in any linguistic sense, just a simple pulse, a mathematical sequence, prime numbers 2, 3, 5, 7, 11, 13. The transmission will occur at 1420 MHz, the hydrogen frequency, the same wavelength, the WOW signal used. The goal is not to provoke a response, though if one comes, it will be recorded. The goal is to demonstrate that we understand, that we detected the 1977 signal, that we recognize the frequency, that we are capable of responding even 48 years late. Some object to the transmission. Caution dictates we do not signal what we do not understand. History is full of examples where contact between civilizations of unequal technological development ended badly for the less advanced. But others argue that caution is irrelevant. If 3i Atlas is a probe, it already knows we are here. It has been observing us for months, possibly years, possibly decades. Remaining silent now accomplishes nothing. The transmission is approved. It will occur at 03:00 UTC on October 28th, approximately 2 hours before perihelion, while 3i Atlas is still observable from Earth-based telescopes. And then, humanity will wait to see if the universe answers. I am writing this the night before perihelion, and I do not know what tomorrow will bring. If 3i Atlas is natural, tomorrow will be anticlimactic. The object will pass through perihelion, emerge on the other side, and eventually fade from view as it exits the solar system. The anomalies will be studied for years, debated, analyzed, but ultimately filed away as an unusual but not unprecedented interstellar visitor. If 3i Atlas is artificial, tomorrow may be the most significant day in human history. Not because of what will happen, contact, if it comes, will not be immediate or obvious, but because it will mark the moment when humanity stopped being alone, the moment when the question, "Are we alone?" shifted from philosophy to fact. I do not know which outcome I hope for. Part of me wants the object to be natural, wants the simplicity of a universe that follows known rules, where anomalies are rare but explainable, where we are still the only intelligence looking up at the stars and wondering. Part of me wants the object to be artificial, wants proof that the universe is vast not just in space, but in minds, that intelligence is not a fluke but a feature, that somewhere out there, someone else has looked up at their sky and wondered the same questions we ask. Both possibilities are terrifying, both are exhilarating, and tomorrow we may begin to know which one is true. The transmission is sent, 03:00 UTC, a pulse of radio waves traveling at the speed of light, crossing the distance to 3i Atlas in less than 3 minutes, and then silence. Telescopes continue to monitor. No response detected. No change in the object's trajectory, rotation, or thermal profile. No emissions. No signals. 3i Atlas continues its approach, indifferent or unaware, moving toward perihelion as if nothing had happened. Perhaps nothing did. Perhaps the transmission was received but ignored. Perhaps it was received and recorded but not understood. Perhaps it was never received at all, lost in the noise of solar radiation, or simply not aimed precisely enough. Or perhaps 3i Atlas is not listening. Perhaps it is not a communication device but an observer, programmed to watch and record but not interact, a silent witness to the civilizations it encounters. We will not know, not today, perhaps not ever. At 05:17 UTC on October 28th, 2025, 3i Atlas reaches perihelion. Distance from the Sun, 0.33 astronomical units. Approximately 49 million kilometers. Well inside the orbit of Mercury, deep in the region where heat and radiation reach levels that melt lead and vaporize ice. And then the object disappears into the sun's glare. For 48 hours we will be blind. For 48 hours we will wait. For 48 hours the universe will hold its breath. And when 3i Atlas emerges, if it emerges, we will finally know. The clock has stopped ticking. Now we wait.